Hello, amazing students. How are you doing? I hope you're doing well. We're going to be going over the Chapter 9 Inequalities Do Your Best practice worksheet. Remember, this is practice for standards 9A and 9B, preparing us, of course, for our test. So as you can see, the first problem's already done for us. We need to make sure that we're always showing our work and graphing the numbers in the number line. I did not answer this question yet, so we'll make sure to know how to explain and show our reasoning, and then we'll do all the other problems as well. So please use this time to check your work and make sure you understand everything, okay? So here we go. A couple of notes before we begin is this one, just a reminder that we have open and closed circles. So if it's open and to the left, we know that this is the less than symbol. If it's open and to the right, we know that it is the greater than symbol. You'll notice the arrows face the same way, right? Isn't that a crazy little trick? The arrow of the diagram matches the symbol. For example, here we have less than, and the arrow is facing to the left, just like the symbol shows us. Right there. Okay, we also have two more symbols. Of course, the symbol with a closed dot is going to be less than or equal to. And the last symbol we have is closed dot and to the right. It's just really good to remember all of these because you wouldn't have to look at notes. Save yourself some time on your test and know the tricks. All right, here we go. Our first question says, is x equals 5 a solution to the inequality? When I say a solution, I mean it's true. For example, if we put the number 5 in here, ooh, number 5 has an open circle. Does that mean it's a solution? No, the number 5 has a hole there because you cannot include the number 5. But how do we show our work? Instead of writing all that, we're going to say x equals 5 is not a solution, but here's the reason why. First reason is this. We know our answer is this. If we know we did it correctly, we're going to get x is less than 5. Well, if we substitute the number 5 in, would it be true? Is 5 less than 5? That's false. Okay. Alternatively, one of the better ways to do this, just to make sure you know that you're doing things correctly, is take your original equation. Again, we're doing this to make sure that we did not make any original mistakes. So we take our original equation and we plug in the number 5. We substitute the number 5. So we get 5 minus 8 is less than negative 3. What's 5 minus 8? 5 minus 8 is negative 3. Is negative 3 less than negative 3? No. It's false. So with one of these reasonings, we can say that the answer is definitely no. 5 is not a solution. All these other numbers over here are solutions, except for the number 5. All right, let's check our answer for number 2. So for number 2, we had to do some inverse operations. Our goal always is to get x by itself. And please make sure that x is going to the left side. Make sure that x is on the left and our numbers are on the right. That just makes sure to have our answer with x on the left. If we have it on the right, then we're going to have to face the arrow the opposite direction, and that's a little tricky. So our first step is to get x to the left. And you know what? Might as well do both things in one step. I want to move the number to the right. So I'm going to add 5 to both sides as well. So notice that the x's cancel out and the negative 5 also cancels out. So we get 3x minus 2x, which is pretty easy. 3 apples minus 2 apples is 1 apple. So we get x is less than or equal to 30. So how do we graph that? Oh, Oh, guess what? I made a mistake. You know what? You know, sometimes your teachers make mistakes. Maybe it's early in the morning or something. But let's see. Negative 3 minus 2 is not 1. Negative 3 minus 2 is negative 5. So if your answer doesn't fit on your graph, that's a sign maybe I made a mistake. In this case, I definitely did make a mistake. So did you all catch that? Okay, I hope that you didn't make the same mistake that I did, and if you did, that's all right. Let's fix it. Divide both sides by negative 5. And here's a great tip. If you divide by a negative, you have to switch the sign. I have to switch the symbol. So it's no longer less than or equal to. It is greater than or equal to. And what's 30 divided by negative 5?
The answer is negative 6.
And we get our answer of x is greater than or equal to negative 6. Again, we only switch the sign, right? This symbol becomes the opposite. You know, switch them. Switch them. If we divide by a negative number. Alternatively, you can graph your boundary point at negative 6 and test the number 0. If you tested 0, you get a false statement. Or would it be true? Let's see. If you plug in 0, would that be true? Yeah. Let's see. If I plug in 0, negative 5 is less than 25. Is that true? Again, what I'm doing is I'm plugging in 0. If I substitute 0 in for both numbers, would that be a true statement? I got a little stuck here. Let's see. Yes. So if I plug in 0, I'll get negative 5 is less than 25. Is that true? That is true. That means 0 is a solution. Guess what I did? I put a dot at 6. Oh my goodness. I made a mistake. My boundary point was supposed to be negative 6. Please forgive me on these mistakes so far. I hope I won't make another mistake. But we know that 0 is a solution, so the arrow is facing to the right. So it says here, is 0 a solution? Let's actually show the work here. We know the answer was true, or yes, but let's show the work for that. So the first way to show this is, we know we switched the signs, so 0 is greater than or equal to negative 6. Is that true? Yeah, that's true. But the better way to check, because it's so easy to forget this switching tactic right here, the switch, is take your original equation and substitute the number 0. And see if that one's true. What's negative 3 times 0? 0. What's 2 times 0? 0. This makes this equation or inequality very easy. Negative 5 is less than or equal to 25. Is that true? Negative 5 is less than or equal to 25. So that is true, meaning 0 is a solution. As a matter of fact, anything greater than or equal to negative 6, this boundary point, is a solution. So the answer here is yes. All right, let's move on to the one below it. I'm going to move on to this one right here. So here is one with a fraction. And what I like to do about fractions is remind everyone, what is a fraction? For example, if I said 2/5, what's another way to say 2/5? Yeah, 2 over 5, right? But it's also 2 divided by 5. So how do you get rid of a 5? You have to multiply by 5. Okay. If I said 1/7, how do you get rid of the 7th? You multiply by 7 because of the inverse operations. Opposite of division is multiplication. So we're going to go ahead and solve this inequality like our typical equation. Typical equation, adding 2 to both sides. and we get a fraction. I know a lot of us say we don't like fractions, but fractions are pretty easy once you've solved a lot of them. So -1 plus 2 is 1. How do you get p by itself now? The opposite of division by 4 is, what is it? Yeah, to get rid of the 4, all you gotta do is multiply both sides by 4. If you knew that, that's awesome. If you didn't, let's practice it, right? To get rid of a fraction, just multiply the denominator by that number, and they will cancel out. So we're going to get 1p. Well, 1p is just p. And 1 times 4. 1 times 4 is just 4. And that's my answer. P is less than 4. So I'm going to put a open circle on 4. Open circle. If you filled it in a little too much, you can make a little note here. He said this should be an open circle. And since it's less than, I'm going to make sure the arrow faces the same direction as the symbol, and that is to the left. Okay, let's go ahead and check our last problem here for the first side of this page. It's this one. This is a very interesting one. Did you notice anything interesting about this problem right here? Yeah, you might have noticed something interesting here. So we're going to add the like terms and see what we get. 6y plus 2 is less than or equal to 6y plus 2. Oh my goodness. The left side and the right side are the same. So what does that mean? Well, there's a couple things we could do. We could subtract 6y. If we subtract 6y to both sides, that cancels out. We could subtract 2, but here's the thing. When I get 2 is less than or equal to 2, is that true? Yeah, this is true. So then in this situation where it's an inequality, that means I could plug in any number for y. Any number for y. And get a solution. So here's the reason why it's one of these. Is it no solution, or is it infinitely many solutions? It's one of these. Can't be both. Which one is it? 2 is less than or equal to 2. Is 2 always less than 2? Or is 2 never less than 2? Less than or equal to 2? Look, since 2 is equal to 2, this makes it a true statement, meaning it's not no solution. The answer is infinitely many solutions because the number 2 is always less than or equal to 2. So I have a question. How do you graph infinitely many solutions? Another way to say infinitely many solutions is all real numbers. So all real numbers includes every single number on the number line. Every single number on the number line. So this would be a way to graph it. Every single number plugged into this inequality would be true. So therefore, it's an arrow facing both directions. Okay, let's go ahead and move on to the next page here to check our work for this one. And we're going to solve this pretty quickly so that we can move on to the next standards, which we're practicing for. Okay, the most common mistake I've seen for this one is the distribution property. If you see that -3, don't forget to multiply both numbers in the parentheses by 3. No, not by 3, by -3. So here's what we get. 3 minus 3x. And what's -3 times 1? -3 times 1 is -3. Oh, wow. Interesting situation here. And we get this. Okay, here's a weird one, but if we get 3 minus 3, 3 minus 3, those would cancel out. So we're left with Negative 3x is greater than or equal to x minus 8. They only cancel out because one's positive, one's negative, so we can just cancel those out. Okay, next up, I'm going to make sure x is all on one side, so I'm going to go ahead and move this x to the left side. And that gives me one of my last steps in this problem. Negative 3 minus 1, negative 3x minus x is negative 4x. And we have a negative 8 on this side. Okay, last step, how do I get x by itself? Yeah, you got to divide by a negative, and here's the thing. Whenever you divide by a negative, you have to switch the inequality symbol. So you can make a little note here that you have to switch the sign. This time, I'm going to add a little highlighting here. The symbol must be flipped. So we get x is less than or equal to negative 8 divided by negative 4. Negative 8 divided by negative 4
It's 2.
is a positive 2. Again, you can always check by graphing your boundary point, closed dot at 2, and seeing if 0 is a solution. In this case, 0 is a solution, so the answer must be everything less than 2. So that would be your answer. Okay, next problem. Same steps as always. Let's get x, or k in this case, on the left, and let's get the numbers on the right. So our first step is to add the 1 to the right side using inverse operations, and subtract 7k to the left side. Okay, you know you could also move the 5k to the right side, but in the end you'd have k on the right. You'd have to switch the sign. So here is another reason why we have to switch the sign. Alright, so 5k minus 7k is negative 2k. And 5 plus 1 is 6. Dividing both sides by negative 2. Good job, everybody taking their notes if they haven't done this yet. If you did it already, check your answer. See if you got it right. Ooh, I made a mistake. It's not less than. I have to switch the sign. 6 divided by negative 2 is negative 3. So I'm going to make a note again. If you ever divide by a negative number, you must switch the sign. So I'm going to make a little note here. I switched the sign. Writing this down on your test is optional. Writing this part down on your test is optional. It's just a little extra. If you want to be extra, write this down. And it'll show that, wow, you really get this. Okay, I'm going to put a boundary point on negative 3. It's going to be an open circle since it's less than or greater than. Greater than in this case. And again, if you test 0, let's actually show the work here for this one. If you test the number 0, I'm going to call this testing 0. If you test 0, would it be true? Let's see. Go ahead and write that down. If you didn't write this down yet, write it down. It's good stuff to do. You plug in the number 0, substitute the number 0 into your inequality, and see if it's a true statement. Now, 5 times 0, 7 times 0, we know is 0. We get negative 1 is less than 5. Is negative 1 less than 5? That's true. That means 0 is a solution, meaning the arrow must be facing towards 0. So if I did not switch my sign, I would have gotten the wrong answer. Alright, we're going to go ahead and move on to these ones right here. Let's move on to this more difficult one first. Or perhaps one of these are more difficult. Let's see. But I'm going to move on to this one next. Alright, let's go ahead and do this problem right here. So, one One thing I like to think about with these problems right here where I'm graphing something where it looks like it's going to be thumbs out or thumbs in situations is one of them is called and one of them is called or. So for example, if it's between two numbers, I want to call that and. Because it's both less than and greater than. It's both, so we want to call it and. And another example is if they're facing out, for example this one, I want to call this or. Okay? It's or because it's either going this way or it's going to the right. Usually negative and positive. So, in this situation, we know it's an or situation. So I'm just going to simply write down the answer is x is less than or equal to negative 4, since it has a closed dot. Or, and yes, please write down the word or, x is greater than or equal to 0, since it's facing the right. And that's it. Alright, let's check the next one. This one's an and situation. So there's two ways to write it. The first way to write it is by writing it like this. X is greater than, since it's open, greater than negative 4. And it's also less than 3. Alternatively, I like to think of these as the between. It's in between two numbers. So what I do is I put x in the middle. I'll put 3 on the right, so it says x is less than 3. But it's also greater than negative 4. So this way is great because it shows you two things. X is less than 3, but also x is greater than negative 4. So you just need to make sure the symbols are facing the same direction. They're facing the same direction versus these ones. They're facing opposite. So again, you choose which one you prefer to write it as, or write them both, that's fine. But really pay attention to those details that you see here. Okay, next one, I'm just going to write this last one as a between, since that's the amount of space we have. X is less than or equal to negative 1. And x is also greater than negative 4. Remember, one of these is closed, the other one is open. So this one has to be equal, and this one not. Again, remember the arrows are facing the same direction for between. And that would definitely be our answer. Alternatively, again, you could say x is greater than negative 4 and x is less than or equal to 1. But if you learn this way, it's just typically a little bit faster. So these would be my answers. All right, let's move on to the true or false questions. Okay, so there is typically an example given to you. 6 is greater than 5 is true. So in this situation, we're looking at the symbols and we're seeing if the situation is true or false. So 31 is greater than or equal to 21. 31 is greater than or equal to 21. Negative 23 is less than or equal to negative 25. Negative 23 is not less than negative 25 because negative 25 is bigger. Wait, negative 25 is technically it's smaller. It's deeper into the negative numbers. Okay, next one, we're just going to evaluate these. The absolute value of 27 is 27. The absolute value of negative 1,000 is 1,000. Turn these positive, and you're going to see that this is a false statement. 27 is not bigger than 1,000. All right, let's move on to these questions. I know we need a lot of practice on these ones. It's typically the most commonly missed questions on our test because this one has, typically, it has 2 solutions. Typically, it has 2 solutions. Remember, absolute value of a number, for example, is equal to 7, has two answers. The first answer is 7. That's true. The second answer is -7. And that's also true. So that means we're going to split this into two solutions. All right, for our first example, we're going to get x plus 2 is greater than 1, the positive version of our answer. And x plus 2 is less than -1. Here's what we do. We take our inequality and we flip it. Why do we flip it? We flip it because the negative. If we make one negative, we need to flip the inequality symbol. And that's really just the only reason why there's two solutions, where typically one is positive and one's negative, but these boundary points could be anywhere on the graph. So let's solve for the boundary points. We're going to get our first boundary point at, let's see, well, let's just show the work for both at the same time, since they're typically the same steps. If I subtract 2 to both sides, I'll get x is greater than -1, or x is less than -3. Let's graph that. The first one is greater than -1, open circle, and less than -3. That would be my answer. That means if I plug in any number here, it will be true, except if I plug in a number in between here. For example, if I plug in -2, would that be true? Plug in -2. What's -2 plus 2? 0. Is 0 greater than 1? No. So these boundary points tell me the answers that are solutions and the answers that are not solutions. Okay, let's move on to the next one. For this next one, we're going to go ahead and split our inequality into two solutions. Again, how many bars are there? There's 2 bars. So it's a reminder that you can actually take these bars and split it up into 2 problems. So I like these problems. The more you practice it, the better you get. So the first inequality, let's see. Can you write them? Let's see if you did it. 3 minus 2x is greater than or equal to 5. What would be the second inequality? Right there. 3 minus 2x. Leave the left side the same. But the right side is where we need to flip the symbol, right? Did you flip the symbol? Greater than becomes less than, and the 5 becomes negative. Okay, here's a little something special. If it was negative, it becomes positive, but if it's positive, it becomes negative. So in this case, we made the 5 into a -5. That's it. Let's solve it. I'm going to start by subtracting 3. That gives me -2x is greater than or equal to 2. My second solution here is going to be something interesting. We're going to get -2x is less than or equal to -8. And let's get x by itself. How do we get x by itself? Yeah, we're going to divide both sides by -2. And we need to flip the sign. Note, I switched the sign. Why did we switch the sign? Because we divided by a negative. Another way to think about this is, if x is negative, you're very likely going to switch the sign. Yes, you are. So I'm going to make this symbol switch. I'm going to get -1. And for my second solution set, I'm going to get x is, I got to switch the sign. This question is very difficult. I think it's pretty difficult. But The idea is we switch the sign, and then we actually switch the sign again for this one. It's crazy. But let's graph it. So our first solution is greater than or equal to 4. And our other one is less than or equal to -1. And that would be our solution set. So let's say this is or. It's this or this. Just like this one. All right, we're going to look at this problem right here. This is actually a pretty special one because these ones were greater than, right? All these were greater. This one's actually less. So let's see if it's any different, if it's a less than symbol. I already split it up into 2 inequalities. You can go ahead and see if you can do this, and if you want to, if you have the ability to, pause the video and see if you can make the same answer. If you already solved it, let's check. Okay? So step 1, let's get x by itself. I'm going to add 4 to both sides, which is true for both inequalities. We get 3x is less than 6, is that right? Yeah. And 3x is greater than 2. Ooh. Interesting situation here. Dividing both sides by 3, we're going to get 2 solutions. The first one is x is less than 2 because 6 divided by 3 is 2. And the second one is x is greater than 2/3. Well, 2 divided by 3 is just 2/3. 2/3 is 0.66 repeating. So I need to graph these 2 boundary points. Let's see what it is. Open circle on 2 and open circle on 2/3. Oh my goodness. You can make a little note that this is 2/3 if you want to. So it says less than 2 but greater than 2/3. So this would actually be my solution. It's only the numbers in between 2/3 and 2, not including those boundary points. So this one's a pretty crazy one, I'll admit. This was a pretty crazy one. This one's actually an AND situation. As a matter of fact, I might as well tell you now, if it's less than, it's typically AND, right? It's going to be thumbs in, like this. And if it's greater than, it's pretty much always going to be thumbs out. So this is something important for Integrated 2. Hopefully your Integrated 2 teachers will show you this, that if it's greater than, it's going to be thumbs out, like this. And if it's less than, it's going to be thumbs in. So just a little bit of a note for the future. Okay, let's do this next one. Check our answers for this one. My recommendation for this problem right here is to first simplify the inequality a little bit. So if I look at this situation here, I can actually simplify it just a bit by doing the distributive property. So I'm going to distribute -2. -2 times 1 is -2. And I can still simplify this a little bit more. So I'm going to. X minus 2x is -x. And now this is where I want to split my inequality into 2 equations, so two different situations. Again, remember, this is actually a -x, so I'm probably going to have to switch my sign a couple of times, but otherwise you can do the boundary points. Boundary points are going to be in between 2 boundary points since it's less than. Remember, I told you if it's less than, it's probably going to be between. In this case, we do have a less than symbol, so it's probably going to be in between, like this and like this. But let's graph it. Let's solve it and graph it. All right, we're going to get the positive version of our inequality and the negative version of our inequality where we have to switch the sign. Okay, I'm going to get -x minus 2 is less than or equal to 5. I think I just wrote that again. Let me solve it. I'm going to add 2 to both sides, which is the same for all inequalities. I'm going to get -x is less than or equal to 7, and negative x is greater than or equal to negative 3. I think I'm not making any mistakes now. I like that. Okay, I'm going to divide by negative 1 to get rid of the negatives. And I'm going to write the little note here. Note, I switched the sign. Otherwise, you do have your two boundary points. Our first boundary point is going to be at negative 7. And our second boundary point is going to be at positive 3. And note, I did make a mistake. I need to switch the sign here, so the symbol needs to switch. That's why we do have boundary points. It's a little easier to do boundary points at negative 7 and positive 3, and then label them in between since it's less than. But one of the most awesome things you possibly could do to determine if it's less than or greater than is to guess what? Test 0. If you put in the number 0, would it be true or would it be false? 0 is less than 5 is true. So we're going to shade everything in between the numbers because that's where 0 exists. Okay, let's move on. We have a couple more to try out. Some important problems. So let's get going. Here's this one. All right, for these problems, remember, we've been practicing them. We have y equals mx plus b, where m is the slope and b is the y-intercept. Okay, but we also have some additional notes. If it's going to be, well, there's 4 different types of symbols. These ones are here. I'm going to go ahead and create a little diagram here to remind you that this diagram is pretty good. Remember, these ones are greater than, so that means these ones are going to be shading above because it's greater. And these ones are less than, so I'm going to go ahead and write down that these ones need to shade below. Both of these are dashed like this, since they're less than. And these two symbols have to be solid, since they're equal to. Okay, so for example, if I give you a problem where it's this symbol, guess what? That means I have to do shade above, since it's greater than, and has to be solid, a solid line. Okay. If I give you this symbol, it has to be shaded below, since it's less than, and it has to be dashed, since there's no equal sign. So in this situation, we're given this inequality. Y is less than or equal to 2/3 x minus 3. So I'm going to make some notes. The first note I'm going to do is I'm going to write down the slope. The slope is going to be 2/3. Next up is the y-intercept. The y-intercept is negative 3, so I'm going to write down 0, negative 3. And I get to graph these dots. 0, negative 3. With the slope of 2/3. Remember, slope is rise over run. So I'm going to go up 2 and over 3. You can follow that same pattern until you have all your dots filling up your entire graph. Now, since it's this symbol, that means I have to shade where? Below, since it's less than. And it has to be a solid line because there's the equal sign. Okay, so together, less than or equal to. All right, that means I'm going to go ahead and write this on my graph. A solid line, and I have to shade below. So essentially, you could just take out a colored pencil or something and shade below. I'm going to show you a different way very soon with the next problem. But essentially, everything below the line is a solution, so you can shade it. I'm going to write down as well that this right here is called my solution area. All right, next one. Y is greater than negative 2x plus 4. So I'm going to write down the notes. Our slope is negative 2. Our y-intercept is 0, 4. Since it's this symbol, greater than, I have to have shading below. Oh, I messed that up. Greater than is what? Greater than is shading. Yeah, greater means above. Shade above. And I have to have a dashed line. So how does that look like? Y-intercept at 0, 4. A slope of negative 2. Well, a slope of negative 2 is negative 2 over 1. So rise is negative 2. Run is 1. So down 2 over 1 looks like this. Let's graph the dots, which are technically they're open circles, but you can go ahead and graph them as dots. All right. I do have to have a dashed line, so I can just take each of these dots and add a dash to it. Add the arrows because it goes on forever, and I'm going to shade above. So in this situation, I'm going to shade above, which means above means on top of, towards the roof. So I'm going to go ahead and shade everything on top of the line. So I'm going to do that trick that I showed you. Just shade to the right or shade up. And this is our solution area. All right, we have 2 more problems to check. Let's go ahead and do that. I think we do have a bonus one as well. So this is a pretty good one. A little tricky. But this one is not in y equals mx plus b form yet, or y is less than mx plus b. So I'm going to take this inequality, and I'm going to solve for y. Well, how do I solve for y? Let's get y by itself. Because I want y equals mx plus b. So what I'm going to do is I'm going to subtract 3x. That gives me negative y is less than negative 3x plus 2. Next up, I'm going to get rid of the negative by dividing both sides by negative 1. And when I divide by negative, guess what I have to do? I have to switch that inequality symbol. So that's going to give us everything negative becomes positive, and everything positive becomes negative. All right. So for this symbol, we know we're going to shade above. Alternatively, test 0. I'll show you how to test 0 really quick. Shade above. Is it going to be solid or dotted? Yeah, that's going to be dotted or dashed. Yes. Dashed line. Our slope is positive 3, and our y-intercept is negative 2. Okay, so I'm going to graph 0, negative 2. Right there. And I'm going to do a slope of 3. Well, 3 is 3 over 1. Rise 3 over 1. Rise 3 over 1. Graph all the dots, which technically should be open circles, but that's okay. I'm going to do a dashed line. Since everything on the line is not a solution. And I have to shade above. So above would be over here in this region. So I'm going to go ahead and shade everything above the line. Okay, remember I told you I'm going to test 0. Testing 0 is a really good method of telling if you shaded correctly. But according to my graph, 0 is a solution. 0, 0 is a solution. Well, if I plug in 0 and 0 into this situation, would it be true or would it be false? Let's write this down. Tests 0. If I plug in 0, 0, would it be true? What's 3 times 0 minus 0? 0. Is 0 less than 2? I think it is. Yeah, 0 less than 2. Yes! That means 0, 0 is a solution, meaning we graphed our solution area correctly. This is the correct solution area because we switched the sign. If we didn't switch the sign, we would have gotten the wrong answer. So a little bit of a tricky problem. I wanted to give you an advanced problem like this one. And yeah, let's move on. This next one is going to be a system of inequalities. So this means we're going to graph two inequalities. For the first one, it's going to be a slope of negative 1/3. What's the y-intercept? Good. It's 4. Do I do a solid or a dotted line? Remember, this symbol right there means it's equal, meaning I have a solid line and I have to shade below since it's less than or equal to. Okay. For this one, let's write the notes for this one as well. The slope is 2/3. The y-intercept is negative 2. Since it's this symbol, we know it's going to be a dashed line. And we have to shade where? Greater. Greater means above. Okay? So that symbol tells us everything that we need. Alright, I think just to make this a little bit nicer for me, I'm going to go ahead and use two different colors on my graph. For the first one, I'm going to use green, and for the second one, I'll choose a different color. So I'm going to put my y-intercept at 0,4. Let's see if you did this correctly. Y-intercept at 0,4. The slope is negative 1/3. Rise negative 1. Run 3. Down 1/3. I'm going to put all my dots until I have a complete graph. Okay, this one needs to be a solid line, which I didn't draw too perfectly, but that is okay. It's solid because of the equal sign, and I have to shade below. So for this trick, I'm going to use the waffle method. The waffle method means for the first one, I'm going to shade down. And for the second one, I'm going to shade to the right. And that will tell me where the solution area is. Okay, again, if we're graphing two inequalities, it's very easy to make mistakes. So it's really good to use colors, use a method like this, and you can tell where your solution area is. So our y-intercept is at negative 2. I'm going to graph that at negative 2. And our slope is negative 1/3. Oh, this is a weird one. No, our slope is what? 2/3. Good, that's a lot better. So the slope of this one is 2/3. So I'm going to go up 2/3. Up 2/3, up 2/3, going backwards. I'm going to put a dashed line, meaning the numbers on this line are not solutions. It has to be greater than. And since it's greater than, I have to shade above. So the trick here is I'm going to shade everything horizontally, and that's going to tell me where my solution is. Okay, so where is the waffle? The waffle is right here. So what I can do is I take my pencil or a color of some sort, and I'm going to go ahead and shade in the waffle a little bit. So since the waffle is where they cross, I can go ahead and say, this right here is my solution area. That is right here. This area is not the solution area, and this area is not the solution area, because the solution is, if it's a system, it's where they both cross. All right, let's check our last final problem. Our final problem on the back has us testing values. It has us doing a couple other things. So if you've made it to this point, you've done great. If we get to this last problem and solve it and understand it, that's even better. So let's flip it to the last question of the day. And of course, it's a difficult one, right? It's a difficult one because it's got two inequalities. So let's do this one carefully. For the first inequality, what's the slope? 2. What's the y-intercept? 4. According to this symbol, do I shade above or below? Less than means shade below. Equal means it's going to be a solid line. So we can graph that. Okay, so for our first one, we have 0, quick. I'm using the waffle method. The waffle method, because it looks like a waffle. Okay, and the next one I'm going to do the same thing, but this time I'm going to shade vertically. Okay, so the slope is, what's the slope? 3/4. What's the y-intercept? 3 or -3? -3. Good. If it's this symbol, is it greater than or less than? Shade above or below? Yes, I have to shade. Greater means above. And is it solid or is it dotted? There's no equal sign, so I know that it needs to be dotted, or what we like to call dashed. So very carefully I'm going to graph these dots. -3, starting at -3. Our y-intercept is where it crosses the y-axis. And the slope is over 4, so I'm going to go up 3 and over 4. Up 3 and over 4. Down 3 and left 4. Down 3 and left 4. Okay, I'm going to do my dashed line. And according to this, I have to shade above. Is that right? Greater? Yeah, greater means shade above. So I'm going to go ahead and use the waffle method. And at this point, we know where they cross. But right here, only right here, is the solution area. Okay. So what I'm going to need to do next is test some points, some coordinates, to see if they're solutions. Well, here's a good thing. If you graphed it correctly, you can see whether the solution is a solution or not. And if you didn't graph it correctly, there's other ways to test. But for this one, let's see. Is 0, 0 a solution? Yes. Is 4, 0 a solution? No. Is 0, 5 a solution? No. Now you might be wondering why. If you got these right, that's great. But you might be wondering why. So for the first one, 0, 0 is a solution, right? Because if we plug in 0, 0 into our graph, it's in this shaded area, which is great. But you can also check it. By substituting it into your inequalities. So our first inequality is right here, and our second inequality was right here. And you tell me if those are true. Is that a true statement? 0 is less than 4? True. 0 is greater than negative 3? True. Okay. Now for the second one, if we plug in 4 comma 0, would it be true? So substituting 0 in for our inequalities, 0 for y, 4 for x, would it be true? Let's see. 0 is less than or equal to 8 plus 4? Yeah, that's true. 0 is greater than this? No, that's false. Again, all we did was plug 4 comma 0 in for our inequalities, and you could tell that this is not a solution. Alternatively, we have a dotted line. Is a dotted line going to be a solution? 4 comma 0 right there? 4 comma 0 is not a solution, so you can say no. It's on the dashed line, which means it's not a solution. Okay, and final one, we have to plug in 0 comma 5. So if we plug in 0 comma 5, we're going to get a true or a false statement. Let's see. 2 times 0 and 3/4 times 0. Y is here, x is here. Now for this first one, we get 5 is less than 4. 5 is less than 4 is false. 5 is greater than 4. That one's true. But since this is false, we know that it's not a solution. You can say no, it's not in the solution area. 0 comma 5 is not in the solution area. It's above it's right above. Alternatively, you can show your work with inequality numbers. Versus 0, 0, you can say yes, it's in the solution area. So I'd encourage you, watch this video again if you want to go over the things you struggled with. If you feel like you understand everything, that's awesome. You're more prepared for standards 9A and 9B, which are coming up on our next test. So that's where we're going to stop the video. I hope you have a wonderful, wonderful, fantastic rest of your day, and good luck, everybody.